Okay, well, hello and welcome. I am Phil Brink, Consulting Coordinator of Colorado Cattlemen's Ag Water Network. I hope it is snowing where you are. I am joined by Sarah Didrikson of Colorado Cattlemen's, and Sarah is in the background helping things to go smoothly. Today, we are going to be talking with agronomist Maya Kuile-Miller. Maya is going to be explaining the essential elements of irrigation scheduling to us. She is a certified crop advisor and owner of Cactus Hill Ag Consulting based in La Jara, Colorado. Her areas of expertise include crop production, nutrient and pest management, and, of course, irrigation scheduling. She also teaches a course at Adams State University called Water 101. So she knows a bit about water and how to apply it on the land. So, a couple of shopkeeping notes. And while I do that, Maya, if you want to go ahead and share your screen. One, today's webinar is being recorded and it will be posted on our website at agwaternetwork.org, agwaternetwork.org, and we will also post Maya's presentation slides. So if you don't feel like you have absorbed everything during the presentation, and you likely won't because we're going to get into the weeds a little bit, you can always go back and view the presentation and the slides again. If you have questions, please feel free to put those in the chat anytime during Maya's presentation. And we will also have a Q&A at the end. And if you want to ask your question verbally, that will be the time to do that. So, Maya, this year our biggest concern is looking like whether we are actually going to have water to irrigate with. But hopefully we do. And so, tell us about the keys to making the most of whatever water we have.
Yes. Can you hear me? I've got this very strange screen. Let me
We can hear you great.
show. Yeah. Let me go to Zoom and see. Okay. I will just get going on it then. Can you see my PowerPoint in a second?
Yep. If you can minimize the zoom,
Yep.
front and center right now. There we go. And then if you
And
want to maximize your slide,
there
there
we
we
go.
go. Looks
All
good.
right. Well, my opinion, because I've been doing this for such a long time, is that on water short years, we'll definitely benefit from being able to apply our water in a more efficient manner. And so that's what irrigation scheduling is all about. Um, so irrigation scheduling is about programming the timing and amount of water that you apply on a crop, and different things that impact irrigation scheduling. I kind of break down the scheduling process into understanding soil water content, and the soil capacity to store water, understanding evapotranspiration, which is the rate of water use by a crop. So evapotranspiration is the same thing as water use. And finally, understanding your irrigation system. So this is how I break it down. And what we'll do during this presentation is talk about
Is being recorded.
understanding your soil, knowing your crop, and knowing what your irrigation system is capable of. It's a little bit of a center pivot focus, so I hope everybody's okay with that, because definitely in terms of acreage, I work mostly with center pivots because I'm in the San Luis Valley of Colorado. And as we know, that's the area of highest center pivot concentration still in the world. But the same principles apply to furrow, flood, side roll, other irrigation systems. So first, I'd like to talk a little bit about soil water terms. Saturation water or saturation moisture is the water that's in the soil where all the macro pores, the big pores in the soil, everything is filled with water. And the saturation water is the water that can percolate and drain out of the soil. by gravity. Field capacity is the amount of water that remains in the soil after all that saturation moisture has left, after saturation water has disappeared. Just a rule of thumb, in sandier soils, sandy loams, 24 hours, if you allow a field to drain for 24 hours without a crop in it, field capacity would be reached. In heavy soils, it may take longer and up to 3 days for saturation moisture to disappear. Permanent wilting point is the other end of the spectrum for water holding capacity, and it's, I put it in quotes, and I should do the same with field capacity, although that is more of a fixed number, because basically it's designed so that we can actually measure it in the lab, but the permanent wilting point for different plants are at different level. But it's theoretically the point at which plants have taken up all the available water for a given soil, and soil can't supply water to keep plants from dying. The available water holding capacity is the water held between field capacity and permanent wilting point. And that is what we'll explore when we talk about soils. So most of the available water holding capacity in soil is related to soil texture. And so on the left-hand side is a chart that kind of goes through the different soil textures from sand, which is, as you know, a kind of very coarse granules with not much water holding capacity. As you can see from the side of the graph, there's just this little short distance between permanent wilting point and field capacity. And then as you move towards clay, really clays aren't that good at holding water either, but in between is where you have soils that can hold a little bit more water. And clays can hold a larger number of water, but there's not much space between field capacity and wilting point. So another component in soils that is of real importance, especially now we hear, we're encouraged by the NRCS and by everyone to improve our soil health. And a big portion of that improvement is improving soil organic matter. So the higher your soil organic matter, the higher your available water holding capacity. And these parts of available water are called dynamic available water holding capacity. And I'm sorry about the acronyms, but those words are kind of long, so they're good acronyms to learn. Compaction, of course, reduces it because it gets rid of the macropores. And then salinity and sodium affected soils, generally speaking, the available water holding capacity is less, in addition to which, especially in saline soils, you probably want to add a leaching fraction for managing your salinity. And that is a whole other course in itself. What I to do is I'll take you to Web Soil Survey, and this is the website is websoilsurvey.nrcs.usda.gov, and we will go find a field somewhere in Colorado. So you press the little, can you see that, everybody, Phil?
Yes, we can see it. You got your mouse on the Start WSS button.
So the friendly green button, you click on that, and I was just using it. So now I'm starting a new session. And a lot of people say their complaint about the Soil Survey of the United States is that when we farm, we change the nature of soils. But honestly, for available water holding capacity, you do not
already
change
going on. So. Oh, okay.
So now there's a bunch of buttons across the top, if you can see my mouse. This is a zoom in button. This is a zoom out button. And this is move around. So you can move your screen. And I'm just going to zoom in on somewhere in western Colorado, I think. Oops, I went too far. So I just wanted to show you all those cool buttons on this screen here. Let's see. I'm trying to find a field. So let me zoom out again. And this is a kind of a useful site for other things as well. Okay. All right. I'm going to zoom in somewhere around Montrose. And somewhere near Olathe or Delta. Just because. So you can continue to zoom in. And this time, I think what I'll do is I'll pick a center pivot field that I see here. So the next step when you're trying to find your available water holding capacity for your field, and you only ever have to do this once in your lifetime, is I'll pick either a freehand. This AOI is actually area of interest. So I'm going to use this AOI, and I'm just going to zoom in on this pivot here. And so I've selected the area that I want a soil map for. You can, if you look on the top of this whole screen, there's the area of interest, and then you can actually generate a soil map if that's of interest to you. And it is kind of interesting because these soils all have different characteristics, and sometimes your rooting depth might be limited by gravel bars and so forth. So you can always look closer at that. But today we're just going to look for available water holding capacity. So we go to Soil Data Explorer. And then again, now we have a subgroup of tabs. These are all like suitabilities and limitations for use, but what I'm interested in is soil properties and qualities. And I'm interested in a soil physical property, which is the available water holding capacity. So I'm going to click on available water capacity, and I'm going to click on the down button for that. And at the bottom here, it tells me, well, what depth do you want to look at? So let's do dry beans. Let's say the sprinkler is planted to dry beans, and we're going to do 16 inches rooting depth. And I'm going to click on inches, but I'll show you in a second what happens. So then I'm going to click, and it tells me that this whole field, 99.4% of it, is mesa clay loam, 0 to 2% slopes, and the available water holding capacity is 0.18. So keep that number in mind, and we will go back. So that's the only piece of information you actually need. If you want to say, if you have a lot of fields and you can't remember all this, you can save these as a PDF by clicking on printable version. And you can give it a title, look at it, and it will generate. You can also do this with soil maps. It'll generate a nice PDF that you can put away in your files. So right now, the field we've chosen is 100%. That's very unusual, of one soil type. And it's got a 0.18 inches per inch water holding capacity. Oop, hold on. So the next step is how much water is available for a given crop. So your available water holding capacity, AWHC, again, is the rooting depth of your crop at the time that you want to know about it. Some crops, it's always a certain depth. But for example, with dry beans, it would depend on its growth stage, multiplied by that available water holding capacity. And we just explored that in soil survey. So the next step after that is studying the management allowed deficit, which is the portion of water a crop plant can extract from the soil without causing more than acceptable harm. And so this is a moving target, as you can understand, because different crops have different management allowed deficits. So it depends on your soil type, right? Your crop and the stage of growth of your crop. So I'm going to go through some. Okay, and then the available water is your available water holding capacity times the rooting depth. So for those beans that we had before, if we said 16 inches of soil at this time of the crop, you multiply 16 by 0.18, and that is how much water is available to the beans. And that is total available water. So the management allowed deficit is actually the percent allowable deficit times the available water. In alfalfa, generally we use a rule of thumb of 50%. Potatoes and multiple vegetable crops, it's much lower. We don't want them to be stressed. And so anywhere from 25 to 35% deficit. For small grains, it's early boot to flag stage. You can let them go to 50%, but then they have a critical growth stage from sometimes from when they're just starting to flag, actually from when they're jointing to early fill. We don't let them get quite as dry because that's when they're flowering. That's when they're determining how many kernels are going to be on each head. And then late in the season, you can dry them out a lot harder. Sorghum, millet, sorghum Sudan, C4 grasses, all of the warmer season crops you can go to 50 to 60%. Corn generally 50%, except about 40% deficit during tasseling, and that's because that's a critical growth stage. Soybeans, dry beans, 40 to 50%, except during flowering. You don't want to stress them during flowering. And then irrigated pastures, sometimes that's more determined by water availability than it is by your MAD, but it's 50 to 60%. So the next step, now we know what our crops management allowed deficit is to determine what the ET is. So that ET is evapotranspiration, which is crop water use. And there's various sources. I left agroengineering here because they have a really good network of climate stations in the San Luis Valley, but generally speaking, that doesn't go outside of the valley. So I'm going to show you how to use CoAgMet to decide what your crop water use was. CoAgMet recently changed their website, and so it's a little bit different, but it's based on a network. And as you can see, it's a pretty extensive network of weather stations across Colorado. I'm going to do the same thing as I did with web soil survey and do a demonstration. So you go to the homepage of CoAgMet, and these are all the stations that are available. Go to Ag Weather Conditions, go to ET. There's lots of other tools, so you can pull up weather data beautifully at this place. We were playing with this a little bit earlier, and it seems like for ET, only the green stations will bring you some numbers. So let's look at, let me see, which one was I using before? I'm going to use Montrose for the previous example, and I'm going to just go look at last year's data. So up here it says select the date that you want to either end date or start date. I'm going to start date it. So I'm going to go to 2025. Let's do July 1st, and we will do, you can do any number of days. We'll do 15 days of water use. And we're going to use the Montrose weather station because it says here it's fully irrigated, and I know it has data. Sometimes these stations don't keep very good data. So the next step, now that I've chosen which weather station I want to rely on, the next step is to choose what crop. So we talked about dry beans. I'm going to get rid of all these other ones, but I'll leave a couple for examples of the differences between.
It's very basic. Like right now she's talking about how to use CoAgMet.
So I don't know about your green updates, but here in the San Luis Valley, it's pretty late in April, sometimes way into May. This year might be different. Dry beans, let's say the guy, oh, this is a pretty good day. So they planted, because they're up in Delta, they planted on the 30th of May, small grains. They planted on April 15th because the irrigation season, I don't know about other areas, but around here it starts April 1st. And so then down here it tells you which equation. So there's different equations you can use. I'm perfectly happy with Penman Kimberly. It's a little bit of an overestimation, but that can kind of be modified by your irrigation efficiency anyway. For those of you who are kind of computer savvy, you can export this as an Excel comma separated value, but you can also copy and paste it. So I'm just going to keep it as a web page. And then here is my crop water use from July 1st to July 15th. And generally, if I'm doing this, I'll kind of, because I want to use the numbers, I'll put it into an Excel spreadsheet. So clearly in July, the water use for dry beans is pretty high, 0.31, 0.29. And I'm using dry beans because at the end, I'll try and fit in a little mathematical conversion with these. So here's our dry beans, and that's how you can figure out your ET. At the end, I'll explain this, but this is kind of a retrospective that allows you to predict what the future ET is going to be. So we might look at, say, we watered on the 4th of July, and on the 7th, we say, oh, you know what? I'm going to see what ET rates are right now. And after some time of practice, I guess, you'll have these numbers in your head. But this is always a great resource to go and make sure that you're in the ballpark. So going back to our presentation, I've showed you that. I'll just remind you the important points to make are to select your end date, start date, your time period that you want your ET for. This is the date you want it to either start or end. And then this is the number of days. And then you select your weather station. And then you also can select your crops. And the importance about this is that crops have different, they're called crop coefficients. And so it's important to put in the correct planting date or green update for perennial crops, because then it gives you a curve of how water use should potentially be. So I've got here crop growth stage is built into CoAgMet using these crop coefficients. But if you are trying to figure out when to irrigate, it's good to know your percent cover out in the field. And the way that you can double guess yourself or double guess CoAgMet, I guess, is that you can say, okay, the percent cover out there is say 50%, multiply it by the the reference ET, which is the maximum ET for that day, and then that will give you what the actual water use was. I just put this in because many crops, especially corn, beans, and especially the small grains, do not like early overwatering. And so I tend to, sorry, this is a super weedy crop, but I just wanted to show you the difference. I tend to look at what my percent cover is, and I'm going to guess this one at 50%, this one at 100%, and then multiply it by the ET. And that means that early in the season, you are not going to be watering that barley very much. And I've seen many, many fields ruined because you have surface water available. And so you irrigate even after the grain is up. And it's an unwise thing because the plants turn yellow and form adventitious roots. Their root system is not great. And corn is similar. You really want to let it go to a 50% deficit in the existing root zone during the early crop development. So what affects ET is solar radiation, temperature, wind, humidity, the crop in the field, right? Stage of growth, we just talked about that. What your soil moisture, what salinity is of your soils, and then how healthy your crop is. So this is just an example. If we compare July 4th of 2023, the crop water use on alfalfa, for example, was 28 hundredths. And on the 7th, 3 days later, it was almost 4/10. And so then at CoAgMet, you can actually pull up this weather. And I just wanted to show you what happened is we went from 83 degrees roughly, maximum, 48 minimum, at 150 miles per day wind run. And we jumped from that to 85 degrees daytime temperature and 232. And so that, and these huge wind gusts, right? Or higher wind gusts. So that was why that crop water use was so much higher. Wind is definitely very impactful, as it were. So if it's hot and windy, use the maximum ET numbers from the last while and try and use a comparative ET number to predict what your water use will be. Cloudy afternoons, I always use about 2/3. Sometimes I only use half of the maximum ET. Cloudy all day, use half of the maximum ET. But remember, you can always go back to the web and get the ET. But like I said, it's retrospective. So the latest ET that you'll get is yesterday's. And then the next step in your irrigation scheduling program is to check your soil. And you can do this through hand tools, or you can do it through a number of different new technology, sensors. In the old days, we used to use something called you could use tensiometers or gypsum blocks, but now there's just a multitude of different sensors, and so that's how you determine your soil moisture at this moment. So shovel, auger, field check using the field method. I'm going to talk about that in a second. And then moisture sensors, like I just mentioned. Here's some of the field tools that I use. I also have, but I couldn't find it when I took this picture, a drain spade. I don't know if you guys have seen those. It's a type of shovel with a long, narrow edge. It's very nice for doing soil profiles. So this is just a regular shovel. Sorry, it's been sitting in the back of my truck. This is my favorite tool, and my particular auger. It's a soil auger from Oakfield. This one I've had for 35 years. So very, very durable, very handy because they don't destroy the roots of your perennial crops or anything else. This is an auger from AMS, and sadly, they've quit producing them. So I'm very sad. I've emailed them, and if you guys want to email them, they're just a tiny bit cheaper than these, and I'll talk about price in a second. This is a push probe, which I generally use just for soil sampling, but in some situations that might work for your soil. These are available also from AMS. And this is a very large, but you can find much smaller ones, bucket auger. I don't use those here in the San Luis Valley because we have way too much cobble in the soil. Plus, it's a pretty heavy-duty tool. I will talk a little bit about the Oakfield apparatus augers. You can get them from Oakfield themselves, or you can get them on forestry suppliers. There's two types. One of them has these sections. And so for shorter people, that works very well. I think it's called a type C. And then this is the tall people auger, which has a longer arm. That's what mine is. I really, really like that. I noticed when I was setting up for this presentation that they now have a heavy duty tip that you can purchase, but it's quite expensive. But the nice thing about it is that it's got this point at the tip, so it's much easier to use. Generally, when I get a new auger in, I will grind it to a point because otherwise they're harder to use. Don't be shocked. These cost $360 up to $450 a piece. But like I said, I've had mine for 35 years, and so it's pretty good value. And then going back to the AMS ones, the website is called AMS Sampling Equipment, and they have just a huge variety of these and some interchangeable handles and really sturdy build. I really like their augers. Moisture sensors, sorry, these are really blurry. I just did screenshots. This is AquaSpy, which our local center conservation district cost shared with growers to install. A very nice capacitance probe. This is Autonomous Pivot, which is also a subscription-based tool. And it's got ground penetrating radar on this white thing that hangs on the pivot. And then this is one I've tried before, and I really like it because the installation doesn't involve digging a hole and slurrying the soil. It just involves you auger it into a narrower hole than you had before. And so you don't disturb the soil structure. There's other ones. Wilbur Ellis, if your supplier is Wilbur Ellis, they own a moisture sensor company, I guess, called Probe Schedule, and basically it's an app, and their probes are really decent, and the app actually works with any of these other sensors as well. You can program them to even work with tensiometers as long as you have connectivity to that tensiometer. In the old days, when I first got my CropX sensors, the software, and including Wilbur Ellis's software, would ask you to tell you what field you were working on, and they would bring up a soil map and tell you where to plant it. And I say, forget all that. So soil moisture sensors should be somewhere at the start position of your irrigation. So on a center pivot, say this is your pivot road, somewhere, and it's going in forward. So somewhere in the start area and in the outer two spans, and I'll explain that in a second. On a side roll sprinkler, I would say at the start setting, the first set on your side roll. Border dike, same, border dike irrigation, put your sensor in the middle of your very first border. Furrow irrigation, same thing. In the case of overhead irrigation, be sure that your sensors are away from where the nozzle spray will reach them when you first start your system. So this would apply to side roll, it would apply to big guns or anything else, because that is always either over or underwatered. It's not what determines your future whatever. And I put this ugly aerial image up because if you have nozzling issues, sensors may definitely be inaccurate, because I would have put my sensor somewhere in here, and obviously we have a plug nozzle or an undersized nozzle in that ring. So for the feel method, because I highly recommend that you follow up on any of your decisions with checking your field. There's a really cool little book from NRCS that you can get at the what website is this? It's the Technical Resource Partnerships. It's the USDA. You can Google it and find it. I think Phil is going to put a link to this, and he also is going to supply anyone who's interested with the PDF version of this book. Usually when I do a hands-on workshop, I will have a book for everyone. This book has really cool photos, and it shows you how to use your hands to determine what your deficit is in your soil and for each soil type. So once you know what your soil type is from your web soil survey investigation, then you can use this little booklet. And like I said, that's going to be available to you. When I first learned from my friend Leroy Salazar, who started agroengineering here in the San Luis Valley, we just had a table like this, and it's still really handy to carry it around. But this table is also available in that booklet if a table works better for you. So where do you check? If you're going to do a field check, always at the start position. On sprinklers, always in front of the sprinkler. If it's running at the time, just to make sure that you gauged it right the last time. Or even if you're irrigating on furrow or any other form of irrigation, in front of your irrigation is a good place to check to make sure that you are calibrating yourself well. And then if you have some concerns, the weather has changed drastically, it's a good idea to check the end position of your irrigation, whether it's flood or sprinkler, to make sure that you're going to start in time. On a sprinkler, like I mentioned in your installation of probes, the outer 2, sometimes maybe 3 spans is a good place to check. And the only reason for that is that if you look at a typical sprinkler, 45% of your acreage is under your outside 2 spans. So it's always a good idea not to sit there and check on the inside. The other problem with the inside is that usually nozzles on the inside are oversized, so you're always a little bit wetter on the inside. So what else do we need to know to schedule irrigations? Is your irrigation system characteristics, efficiencies. I'm just going to go real quick through this. The irrigation efficiency of your system is the percent of the water that you apply that actually goes to the crop for the crop use, for crop water use. So generally speaking, rule of thumb, sprinklers run 80% up to 95%. And if you are a good scheduler, you can get yourself way up there on efficiency. On side rolls, 60 to 85, I'm sure you could even be better. Surface or flood, 35 to 60%, depending on the type of system. And then wild flood meadows really depends on water distribution, because often that is part of the problem in your sub-irrigating. So for sprinklers and side roll, it's really good to have a current percent versus depth chart, or at least have an idea of how much water you're applying in a given time period. And I put current as the very big focus here, because what happens often is I'll go start working with a person who's never done this, and I'll look at I ask him, do you have a percent versus depth chart? And they say, oh yeah, it's the one that came with the sprinkler 20 years ago. And often that is not the best idea. So design flow is often not actual flow, and nozzle charts are often based on untested flow and pressure. And so it's always a good idea to have a pressure gauge if you have a sprinkler. Check your pressure, make sure that you are working within the parameters. And there's well meter testers all over Colorado. They can give you a flow on a sprinkler. So are you operating at the correct pressure, at the design pressure? So declining water, if you're using a well, will really show up, and the wrong pressure leads to bad problems. And again, the biggest impact will be in the outer 2 to 3 spans, which is, again, 45% of your acreage. Another one that I've come across often on center pivot irrigation is a gearbox went out and the center drive was replaced with something off an old sprinkler or off the shelf in the shop, or just replaced in general, or the ground was rented out to somebody who put in a different gearbox, and that can lead to some real serious issues. So it's always good to keep your percent versus depth chart up to date. Just to show you the impact of pressure changes. So this guy originally had 900 gallons per minute at 32 PSI, and lo and behold, his pressure dropped 10 PSI at 746 gallons per minute. And this is just an example of a percent versus depth chart, if you guys haven't seen that. So what they tell you is that you are applying this depth at a dial setting of this. These dials tend to drift if you still have a manual dial, so be aware of that. And then this is the number of hours it's going to take to get around at that depth. So poor John Smith had 32 PSI. Something happened to his well. He's got 22 PSI. And so he was trying to irrigate 7/10 of water. And so he was set at 26%, and suddenly with this pressure drop, he's only applying 6/10 of water. And here's some examples of aerials where we have pressure problems. So you tend to see, like I said, you tend to see the yield decrease on the outer spans, and you can really see those clearly if you have access to imaging. Here's a change in a center drive. Suddenly we went from 10.7 hours to 6.9 because, they changed that center drive and didn't change their chart. And so suddenly, instead of 1800ths of water applied at 100%, we're applying 12%, and that gets really big at the higher irrigation depths. So that was a lot. And how do we put this all together? How do I actually schedule irrigations? So first, you ask yourself, what is my management allowed deficit? What depth will I use to irrigate? So management allowed deficits, and I know this is a lot of formulas here, is the rooting depth of your crop at the time that you want to know that, multiplied by that available water holding capacity from Web Soil Survey, multiplied by the percent management allowed deficit that you assign to the crop. The MAD divided by irrigation efficiency is what your depth is going to be. And I'll do a quick example in a second. So you need to know how long since you last irrigated. So keep track of that. what was the ET for those days, what was the rainfall over 0.1 inches. And so do a field check, but you can also calculate where you're at today by taking your ET by the number of days or adding up your ET for the number of days since you watered, subtract your precipitation, and that should be your deficit in the field. And when you hit this MAD up here, then you will irrigate. Keeping track of rain. My favorite rain gauge used to be the one on the left. It's called a TrueCheck, Edwards manufactured TrueCheck rain gauge. But the ones on the right are a lot more accurate. And sadly, these I just checked yesterday on Amazon. The price for these is about the same as this one. Some of the little rain gauges you get for freebies have a very small opening at the top, and I don't think are as accurate. But ultimately, if you really want a good rain gauge, go for the one on the right. They're about $30 a piece. So typically, alfalfa and irrigated pastures, this is how much we would water. Potatoes. So on alfalfa, for a new stand, you're watering lightly because it's a very small seeded crop. Once it's established, you're going to calculate your 50% available water, and then you will irrigate with about that much water. Potatoes, soybeans, dry beans, peas, some vegetables, you plant into a wet profile, and then your irrigations later will vary in depth. And then for small grains and small seeded vegetables, you want to keep the seed wet early, make sure that it's in good moisture. Once it's emerged, you will be irrigating with these kinds of depths. And that's just so you have an idea of the depth. So I've got a real quick example here. Dry beans at Bloom in Montrose. My soil was not the one that we just picked, but you could sub in the 0.18. So 16 inches rooting depth multiplied by 0.16 inches per inch water holding capacity of my soil, multiplied by, I'm only going to, since they're at Bloom, I'm going to allow a 40% deficit. So you are going to allow a management allowed total deficit of 1.02 inches. And then how much depth does that mean? It does not mean a 1.02 inches depth. So let's say at 90% efficiency under a sprinkler, you would be looking at an irrigation depth of 1.15. If this was flood ground, it's not as easily controlled, but you would divide by the efficiency of your sprinkler, or on a side roll, same thing. Then here in this example, I irrigated 4 days ago. The ET was 0.3 plus 0.3 plus 0.15. This was a cloudy day. This was a partly cloudy day. I ended up with 0.99 already of deficit, but I had a rain on this 1500th day. I had 0.2 inches. So my deficit is the ET minus the precip, so 0.99 in 4 days minus 0.2 rain. My current deficit is 0.8. So if looking at the backward, right, if today is going to be sunny and clear, it's going to be 3/10. And so today I will irrigate, because if it's supposed to be windy and dry, the ET will be 0.3, and I will start, my MAD will be reached. So if you're surface irrigating, you would start in the morning, but if you're on a sprinkler or a side roll, you might start a PM irrigation. I keep track of irrigations this way, and actually this is a prediction of irrigations. So it's always a good idea to keep track of your checkbook. So write down when you watered with how much, where, and keep track of it. And then using your CoAgMet ET data, you can predict when you will need to irrigate again. But I would say check before you start the sprinklers or the side roll or the irrigation. Anyway, if there's any questions, I'm happy to entertain them.
Okay, thanks. Well, Maya, I'm shocked actually that you don't have a bunch of questions in the chat. That was a lot, but you did a great job of explaining it, I thought. It seems like one of the things that we often don't necessarily focus on, probably as much as we should, is measuring, whether it's through a meter or a flume or a weir, because it seems like where we were kind of focused on center pivots or sprinklers, the same is really true if you're surface applying with gated pipe. You really need to accurately measure that with a flume or weir.
Correct.
And
Yeah.
I wondered if you could go back a little bit just on that exercise of management allowed deficit and just talk through maybe a couple of other examples of, let's say the one you used was, I think, 40% for like if you're in the flowering stage, you don't want to allow that water level to get too low. If you were to use 60%, what would that look like, for example?
Okay.
How much would that change?
So what was your thought? Actually, I've got my.
So if we let's just change that last number. We're gonna change that to 60% instead of 40.
Oh, like here on your irrigation depth. Correct. I got
Up
it.
here where you're 40 over 100, 40%.
Oh, okay. So this is at bloom. Say late season on drag beans, you don't want to water much at all. But we're going to go to so we're going to take our 16 inches of rooting depth, multiply by, I should put the calculator, 0.16 inches per inch, multiplied by 0.6. So you're going to allow 1.5 inches. And then if you weren't on sprinkler, and this is a very high efficiency here, 90%, say if you were doing row watering at 40% efficiency, you divide that by 0.4. And so what you're actually applying is 4 inches of water if you're furrow irrigating, or you aim for that.
Okay. Well, if anybody has a question, you're welcome to at this time unmute yourself and ask it verbally if you don't want to put it in the chat. We'll wait a minute or two.
Well, I'll put my contact information up as well. So if you had any questions or anything you wanted to ask me about, you're very welcome to take this contact information down and do so. Well, gosh.
Looks like you were just crystal clear. Well, I am surprised we're going to be able to end ahead of schedule, I think. So just a reminder that we will post this on our website at agwaternetwork.org, both this webinar and the presentation that Maya just gave in terms of her PowerPoint slides. And I'll do a highlights document, which just touches on the main points. And then I'll also include a link to that NRCS bulletin that Maya referenced there on soil moisture by feel and appearance. And that really is a useful document to just have. And a lot of times, if you, especially if you have a smaller field and you don't want to complicate your life, you may not want to get involved with soil moisture sensors and things. They can get about as simple or as complex as you want. But if you have a shovel or a soil probe that you use to pull soil samples, you can pull those out and use that feel and appearance method that NRCS has developed, and it actually works pretty darn well. So with that, Maya, did you have anything else to add?
No, thank you for inviting me.
Well, really appreciate you taking the time. Did a fantastic job. And we're going to go ahead and conclude today's webinar. So thank you everyone for joining us.